quick uses on biomass conversions.
Good morning, everyone. Thank you very much for giving me this opportunity to present my talk with the title Biomass and Biofuels in the U.S. Clean Energy Transition. So at first, I would like to introduce our campus, Washington State University. Located near the largest river in the Pacific Northwest region of North America, and this is based where I work. This is a Tri-City is the the branch campus. Our main campus in the Pullman, so about 2 hours drive from Brisbane. And about to avoid confusion, so our campus is in Washington State, while the capital of U.S. is Washington D.C. So it's about 2 days non-stop drive, or about 6 hours flight. So the biggest city here in the Washington State is Seattle, which is you must be familiar with, and we also famous with Washington apples. So to the north of our campus, this is our campus. So to the north of our campus is located PNL, Pacific Northwest National Laboratory. This is one of the national laboratories under Department of Energy. So the PNL has main strengths, which is the innovation that advance energy resilience and also enhance national security through nuclear materials and threat analysis. So here are some power generators in the state of Washington. So we are blessed with many types of clean energy. So we have many wind farms due to very strong wind, and Washington State geography is quite unique. So half of the state is green and half of it is desert. So our campus located in the east part, which is desert, so very dry. And we also have the Grand Coulee Dam, which is located at the Columbia River, so it's the biggest river. So it is a massive hydropower generator or water pumping source, the largest hydropower producer in the U.S. And there's also a Columbia Generating Station located in Hanford, also in the banks of Columbia River, about 10 miles north of Richland. So it is the Pacific Northwest only commercial nuclear energy facility, and it's the third largest electricity generator in Washington State, behind the Grand Coulee Dam in Columbia River. And also, this is a Hanford site. Maybe you know the Manhattan Project, the Oppenheimer movie. So this is the first full-scale plutonium production reactor in the world, but so it's not active anymore. But the clean-up process due to the waste underground waste is still going on. So and federal need to spend millions of dollars a year for this clean-up effort. Okay, so now let's look into the energy consumption in the U.S. and Washington. So in 2023, petroleum is the largest energy source in the U.S., followed by natural gas, and with the same share of nuclear, coal, and renewable energy at 9%. So renewable energy itself is mostly derived from biomass, so about 60%, consisting of biomass waste, biofuels, and wood. And for Washington State itself, so the major consumption by source is coal, natural gas. So the first one is the petroleum, and then followed by the for electricity, and then natural gas, renewable energy, and coal. So here's in this figure we can see that the U.S. is the largest producer in the world for both natural gas and oil. However, the supply of these fossil fuels are getting depleted, demanding a new energy source to keep up with energy demand. So here comes bioenergy derived from biomass as a solution to meet this demand of bioenergy or biofuels. So why use biomass for biofuels? So among the main advantages of replacing fossil fuels with biofuel is the reduction of greenhouse gas emissions such as carbon dioxide. So the life cycle of biofuels allows carbon dioxide to be recycled because the gas emitted by burning biofuel is approximately equivalent to that used in the biosynthesis of the renewable sources. So maintaining CO2 consumption and release may less. So cellulosic ethanol, for example, has the potential to cut greenhouse gas emission by up to 86%. However, there is currently no commercial cellulosic ethanol production in the United States because of the technical and economic challenges. And we'll talk about this later. So biomass for biofuels. So biomass is abundant and is domestic resource. So there are a lot of biomass source in the US. So it can strengthen energy security independence, supporting US agricultural and forest product industries, generating US jobs and revitalizing rural economies. And so for some of common feedstock for power is paper mill residue, lumber, peat scrap, and municipal waste. And a common feedstock for biofuels is corn grain for bioethanol and soybean for biodiesel. However, for future feedstock, this is the next generation of biofuels. We use agricultural residues and dedicated energy crops like alfalfa, switchgrass, and algae, etc. And these crops, the future feedstock, can grow on marginal land that doesn't support intensive food production. So replacing fossil fuels with biofuel can reduce some undesirable environmental impacts of fossil fuels production and use, including conventional and greenhouse gas pollutant emission, depletion of exhaustible resources, dependence on unstable foreign energy suppliers. However, it has some drawbacks due to the food and fuel debate in high land and water resource requirements, air and groundwater pollution risk, and the potential for higher greenhouse gas emissions than some fossil fuels if it is depending on how the feedstock and the production process is used while generating the biofuels. So far, biofuels can be classified into 4 generations. So the first one, the generation that will use food crops such as cassava and corn grain for bioethanol and soybean for biodiesel. And the second generation use agricultural waste, forestry waste, grass, industrial waste such as corn stover and waste straw for bioethanol production or biodiesel. And then the third generation use aquatic crops such as algae for biodiesel, bioethanol, and biomethane. And the fourth one using genetically engineered organisms to produce ethanol and other fuels. So there is another classification that can be used based on the greenhouse gas emissions that takes into account direct and significant indirect emissions, including land use change. So advanced biofuels can achieve 50% greenhouse gas reduction, while cellulosic fuels can even reach more than 60% greenhouse gas emission. So in this figure, so here we can see that the fuel ethanol is the largest biofuel produced in the US, followed by renewable diesel and other biofuels and biodiesel. As for production per state in 2022, Iowa is the greatest bioethanol producer as it is the largest corn producer in the US. So therefore, most bioethanol produced in the US is still first generation biofuel from corn grain. So to anticipate the competition with food and fuel debate and land use changes, research on the second generation biofuel is massively conducted, with corn stover as the major feedstock investigated in many studies due to its abundance. So this is the from NREL. So NREL is one of the national lab under Department of Energy, DOE. So they have intensely conducting research for renewable energy because NREL is National Renewable Energy Laboratory. So here they make some the purity of the biofuel production. For example, here green or sugar ethanol is the commercially proven fuel technology, so the most mature, and also the biodiesel, green diesel, and gasoline, and the cellulosic ethanol is still in the mature because a lot of research are needed to make it commercialized, and then up to down to this table, we can see it's butanol, pyrolysis liquid, syngas liquid, diesel, jet fuel from algae, and hydrocarbon from biomass is least nature. And this is we can say it's a very important report by the DOE. So the report shows how the US will be able to meet its target to produce 1 billion tons of biomass for different purposes, including food, feed, fiber, and export. So the US would like to keep their strength on the production of the. And these figures show the strength of US agriculture as US become the largest corn producer in the world, and the second soybean producer, and the fifth wheat producers in the world. And this is the wheat straw, and this is the corn stover. So as we drive across the United States, it is very easy to spot this kind of landscape. So the vast fields of corn and wheat fields stretching endlessly along the road. So because of this enormous amount of this agricultural waste, so many research or studies conducted on biofuels using these two types of biomass as their feedstock. So this is this chart here that shows how important corn is to U.S. industries. So many product derivatives can be produced from corn, and bioethanol here is one of them. And this is soybean, the same, this is similar to corn. This chart shows how important soybean is to the U.S. economy, and also it's included bioethanol. And the figure here shows how these two food crops have been used as biofuel in quite a big percentage, about 30%, 36% for corn to produce bioethanol, and 45% of soybean to produce biodiesel. Now let's look at the lignocellulosic biomass. So if we are talking about second generation bioethanol, we will use non-food biomass. So it's agricultural waste, so mostly it's lignocellulosic biomass. And that's come the challenge because of the chemical structure of this biomass. So the lignocellulosic biomass comprised of three main components: cellulose, hemicellulose, and lignin, and they are tightly bound together. And to be able to, for example, use for bioethanol, we need cellulose. So to be able to extract cellulose from this lignocellulosic biomass, we need a certain technology to separate them, and also because the lignin is highly recalcitrant, hence the process called pretreatment is needed to fractionate biomass for biofuel conversion. So pretreatment of biomass is usually the first step in converting lignocellulosic biomass into fuels or chemicals, making cellulose easier to hydrolyze by eliminating hemicellulose and lowering cellulose crystallization.
Kita eliminer.
So here take a look of the biomass pretreatment. So here you can see that the lignin, the cellulose, and hemicellulose. So each of these component of biomass can be used to generate a lot of products. So, but for bioethanol production, we only need the cellulose and the hemicellulose. So that's why the pretreatment is needed to break this the tightly bonds. So the pretreatment biomass is very costly. However, this pretreatment is very important because they can increase productivity, thus making the subsequent process like fermentation or enzymatic hydrolysis easier. The primary goal of pretreatment is to extract hemicellulose, break the lignin bond, and gain a complete entrance to the cellulose from the plant cell wall medium. So in the table here, we can see that different kind of biomass have different percentage of the cellulose, hemicellulose, and lignin. Here we can see the bamboo have like 41%, but in the sugarcane bags only 35%, and also lignin contents. We don't like lignin content for bioethanol production, so usually we will choose the one that have lower lignin content for bioethanol production. And also, this is a different treatment process that can be used to fractionate lignocellulosic biomass. They can be physical, such as ultrasonication, microwave and milling, and chemical, such as dilute acid, alkaline pretreatment, ionic liquids, deep eustatic solvent, and a physical chemical can be ammonia fiber explosion, and the biological enzymatic pretreatment, bacterial, microbial, and fungal pretreatment. The conversion process can also be classified as the thermochemical and biochemical growth, and bioethanol is mostly used. It's mostly produced through biochemical conversion because it's used chemical pretreatment and to release the cellulose from the biomass, followed by the enzymatic hydrolysis to produce sugar, and later they use yeast fermentation to produce ethanol. This is the conversion process that can be done after pretreatment to produce biofuels. It can be in the form of hydrolysis, combustion, compression, liquefaction, pyrolysis, torrefaction, and many other kind of processes that they can produce this different kind of biofuels. And this is the closer look of the bioethanol production from lignocellulosic biomass. So first we do pretreatment, chemical pretreatment, acid, alkaline, ionic, ammonia, biological using fungi, and the physical, chemical, mechanical, the hydrolysis. We can use acid hydrolysis or enzyme hydrolysis. And then the fermentation can be different type of fermentation, the separated, the simultaneous saccharidic fermentation, or also the simultaneous saccharidic and co-fermentation. And after that, we get the bioethanol, but before we can use it as a fuel, we need a purification step, plus distillation, dehydration, absorption. And here is the biogas production, where biomass at first is pre-treated, the pretreatment, either physical, chemical, or biological, to break the bonds among its main components, and then is followed by anaerobic digestion. As for bio-oil production, that can be used as an engine fuel. Biomass is converted using pyrolysis, the thermochemical using pyrolysis or liquefaction, and then it will produce biocrude. So we need catalyst for this to make to get a high yield of our targeted product. And after we get the biocrude, we need a separation process, condensation, extraction, and we can get the bio-oil as our desired condition. And here's the renewable diesel synthesis growth. So renewable diesel is produced through hydrotreating, and it is drop-in fuels, means that it is chemically equivalent to petroleum diesel and can be transported in petroleum pipelines and sold at a retail station without blending with petroleum diesel. It is different with biodiesel, because biodiesel is produced by esterification of vegetable oils and animal fats, and has a slightly different composition with diesel, so that it cannot be used as a drop-in fuel. And here is the conversion method to produce biojet from biomass. Now, so as previously mentioned, there are barriers for commercialization for biofuel, especially the second generation of bioethanol. So these challenges included the high-risk technology, the pretreatment technology cost, because the chemicals, the enzymes, and the energy consumed during the process is very high, so the higher capital cost, and then the technology scale up, because the result that we get in the lab is not always transformed the same when we scale up. So then the feedstock collection and delivery cost, and the feedstock availability and variability. So one of the solution can be in the form of integrated pre-processing to produce commodity feedstock, so that to reduce to anticipate the effects of the feedstock variability. So many consortia in the has been formed under the Department of Energy, so where different national labs are working together to answer different bioenergy challenges such as bioprocessing separation consortium, feedstock conversion interface consortium, and the co-optimization of fuels and engines. And for the feedstock supply logistic, so the current centralized system can be replaced with an advanced depot system, which is decentralized, aimed at reducing transportation costs and reduce treatment time. So because the location is scattered and it's very wide like area, so that a depot system to tackle this issue. And to mitigate the high cost of biomass to fuel and to maximize the output from biomass conversion of concept of biorefinery has been introduced, where this facility integrates biomass conversion processes and equipment to produce fuels, power, and chemicals from agriculture, forest, and waste feedstock. So by producing multiple products, a biorefinery can take advantage of the availability of different biomass streams and process intermediates and maximize the value derived from the feedstock. So the latest concept is to combine this integrated biorefinery, where it combines biological conversion process with facilities to generate fuels, electricity, heat, and value-added chemicals using lignosulfide biomass in a circular bioeconomy approach, where in this circular bioeconomy approach, the material is used for as long as possible. So here's another example of a biorefinery approach in development of the catalyst that is used during pretreatment. So the biomass ash. So ash is the one of component in biomass, especially the waste biomass, because it's the waste. We gather the biomass from the field. It's like mixed with the soil. So a lot of high ash content, it can, if we don't do something with it, it can impact the efficiency of our processing steps later on. So in this case, the acid biomass is reduced, and then this later on be used as the catalyst in the pretreatment. So here we can see that the biomass residue with a high mineral content and biochar from lignin and insoluble solids generated from the fermentable slurry are used for catalyst production to produce the catalyst. And other than that, the ash can also be used as soil amendment. A type of so this kind of study has been recently been used, like been investigated by many, where the solid residue and liquid of biomass conversion or biomass refinery can be used as fertilizer. And this is also some of so there are many government policies and funding that promote and enhance the production of fuel in the US, such as this renewable fuel standard, the Clean Energy Resource Act funding from BOE, Energy Technology Office. And this is some implementation and current status, like there are over 200 ethanol and biodiesel plants, but mostly the ethanol is still like first generation ethanol. And there are also some commercial scale biogas facility supplying pipeline quality RNG, and then the expansion of sustainable aviation fuels. So there's our building, our lab vessel. We have the sustainable efficient fuel analysis, which is has been the standard, high standard. So many industry research send their samples to our laboratory for this sustainable aviation fuels analysis. And thank you. Yeah, back to moderator.
Okay, thank you very much, Mrs. Fitria, PhD, for your comprehensive and insightful presentation. You have clearly highlighted how biomass and biofuels play a crucial role in the U.S. clean energy transitions, not only by reducing greenhouse gas emissions and supporting agricultural industries, but also by providing a pathway toward greater energy independence. Where this discussion has currently challenges such as feedstock supply, technological scalability, and economic viability give us a realistic understanding of what it takes to integrate bioenergy and effectively the broader clean energy system. So once again, thank you, Mrs. Fitria, PhD, for sharing such a valuable insight that can inspire our future research and collaborations in advancing clean and renewable energy initiatives.
Thank you.
So we will open the discussions, question and answer sessions, and participants may raise their hands or type their question in the Zoom chat box, and I will select two of the questions for Mrs. Fitria. So while waiting for another participant to conduct the question, maybe as a moderator, I'd like to give you the first question. Oh, before that, I'm changing to Mr. Siono Tamrin to give the first question to Mrs. Fitria. Mr. Siono, the time is yours.
Thank you very much, Mbak Fitria, for the very good presentation, very comprehensive about fuel and biomass and biofuel. My question is only one. I want to know about your personal opinion about the policy of the government of Indonesia in implementing the using co-firing, co-firing by using biomass, yeah? And because this policy, some organization in Indonesia, such as Forest Watch Indonesia, they don't agree with kind of policy because they always claim and tell us that biomass energy generation in United States, even in the first country, found that kind of generation in UK also failed to operate, and they stop, they lock down now, they shut down now. Why the scientists always telling us that the biomass is the best way to to use it in the transition of energy transition today. Please. Thank you very much.
Yeah, thank you, Dr. Siono, for your question. So about the co-firing, I'm not really. So is co-firing biomass with what?
Yeah, usually in the firing is we add also biomass. We use the wood chip to put in the.
So it's power, right? Power, not biofuels.
Power. We are talking about the power.
Okay. Yeah. So about biomass, so in US, like there's been many years they are working on second generation biofuel, bioethanol, right? Like they started back in mid 70s, 60s, like 1960, long way back, but they still do it. Why? Because US know that the fossil fuels, they cannot depend on fossil fuels forever. I know, like we know, they keep generating more and more fuel. Like they have the shale oil, so they have a lot of fossil-based fuels. Still, they are the largest producer in the world. But they know they cannot do this. Like they cannot be like this forever. So they need to find alternative. And biomass is like based on many studies, they can feel this challenge, right? US has a lot of agricultural land, and also they have a very vast land area, and also there's and the technology. That's the key point, right? The technology. Biomass feedstock. That's why they have the billion-ton reports. The billion-ton that they have to make sure that they have enough biomass to be able to support their biofuel production. So yeah, now we see that this technology is still like far from the commercialization, but we have hope. That's why I think the research. That's why they're willing to spend like $billions for this research. Even though like now in the government shutdown now, the U.S. government shutdown, so that Trump administration the climate change is not really favored. So many research funding now in U.S. they're getting this renewable energy. It's like we have a lack of funding on that field, but because they believe, some of them believe that we have enough oil, we have enough fossil fuels. Why we still need to spend our $billions on bioenergy? But this kind of policy it keeps changing. But the research shows that it is worth doing. The biomass for bioenergy is worth doing. So yeah, that's what I take my take on that. So in Indonesia now maybe the first generation, but we're not like in that. Not many industries on first generation bioethanol, right? For biomass, yeah, it will be maybe it's still worth doing. That's what I think. Thank you.
Okay, thank you very much for your explanation. In that, for the forest watch Indonesia, maybe only because of they only know the story of the electric generation by the biomass in United States, and so maybe they promote us that not a good policy to work on it. So maybe they propose to use the simple one like the PV or maybe hydro power generation. Maybe that.
Yeah, that kind of energy also we need to develop, right? So, but biomass itself,
yeah,
I don't think we need to
I think biofuel is good, but biomass, we see a lot of things.
Yeah, maybe not as the main point, but I mean, like other energy, like hydropower, is better, but it's still worth trying. That's what. Yeah, they're not wrong, but maybe for now, we can submit for the biomass.
Thank you so much.
Thank you.
Thank you for Dr. Sion Tamrin for the question. We're going to contact the next question from one of the representative of the participants, Mr. Aryawan Hartomo.
Thanks.
Wait, let me check. Okay, we're going to get the questions from the comment sessions. Let me read it for Mrs. Fitria. So regarding your earlier presentation, Miss, in which you explained that biomass uses anaerobic microorganisms and produces CH4